Assalamu alaikum. Welcome to part 3 of trigonometry. In this part, we are going to build up on the concepts we studied in part 2. Like I said, we will be going to do a lot of questions. So without any further ado, let's start. First up, we have an identity which we have to prove. This is quite basic. Well, at least it looks so. So, okay, let's start. Tan square x plus 2. Sine square x upon cos square x is the same thing as tan square x plus 2. The whole thing divided by sine square x upon cos square x plus 1. Okay, so we're going to solve this into 1. We get sine square x here. And if you multiply this by cos square x and multiply this as well as by cos square x, we get 2 cos square x divided by cos square x sine square x plus 1 into cos square x into cos square x. So we get this. Okay, sine square x plus 2 cos square x upon cos square x. We will reciprocate this. Sine square x plus cos square x. This and this cancels out. And we are left with sine square x plus 2 cos square x upon sine square x plus cos square x. Okay, so we're going to solve it further. Now we know that sine square x plus cos square x equals 1. All right, so we can just write 1 in the denominator, 1, and in the numerator sine square x plus 2 cos square x. All right, now we have to show that this this equals 1 plus cos square x. Now remember that sine square x plus cos square x is equals to 1, which means that sine square x equals 1 minus cos square x. All right, 1 minus cos square x plus 2 cos square x upon 1, and we have 1 plus cos square x, and we have proved our identity. Now here is another identity. Let's start. Cos x divided by tan x, which is sin x over cos x into 1 plus sin x. All right, cos x divided by sin x, 1 plus sin x upon cos x. Now let's just open the bracket. Sin x plus sin square x upon cos x. All right, cos x uh, cos x multiply by cos x upon sin x plus sin square x. Now this will multiply and give us cos square x upon sin x plus sin square x. Okay, so we need to prove 1 upon sine x minus 1. You must know that sine square x plus cos square x is equal to 1. So cos square x is equal to 1 minus sine square x. So we'll just apply it here. Okay, so 1 minus sine square x upon sine x. Let's just take sine x common. Sine x 1 plus sine x. So now what we can do is notice that this is an identity a square minus b square, which is a plus b, a minus b. All right. So sine x 1 plus sine x. This and this cancels out, and we are left with 1 minus sine x upon sine x. And we have to prove 1 upon sine x minus 1. So we can easily prove it. 1 upon sine x minus sine x upon sine x. This can be rewritten as this. This and this cancels out, and we're left with 1. So 1 upon sine x minus 1. And this is what we had to show. So we have this other question with us. Let's start. Now notice that this sine x upon 1 plus cos x is already in its simplest form. And we need to get it into this form. We have to prove this basically. And cosec x is 1 upon sine x minus cos x upon sine x. So essentially, we have to get it into this form first so that this can be proven. All right. But the problem is that this is already in its simplest form. This right-hand side is already, sorry, left-hand side is already in its simplest form. So what we can do here is that we can multiply sine x upon 1 plus cos x by its conjugate. If we do not do this, we have unfortunately no other option. So we are going to just multiply it by its conjugate. Okay. So that gives us sine x 1 minus cos x upon 1 plus cos x into 1 minus cos x. So if we cancel this and this out, we will get this again, which we don't want to. So what we can do here is sine x upon 1 minus cos x. Now notice that an identity here is being applied. And what, see, this is a plus b, a minus b. So a square minus b square. All right. This identity is being applied here. So we can safely do this. And then we can write this as sine x upon 1 minus cos x upon 1 minus cos square x. All right. So what next? We need to prove this. So what we can do here is notice that sine square x plus cos square x is equal to 1. We know this, all right? So sine square x is equal to 1 minus cos square x. So we can write sine square x here, all right? So let's just do that. sine x upon 1 minus cos x upon sine square x. All right, this and this cancels out. So we are left with 1 minus cos x upon sine x. And we need to prove that, and we need to prove this first. All right. So yeah, we can write this as 1 upon sine x minus cos x upon sine x. 1 upon sine x is cosec x, and cos x upon sine x is cot x, which is what we needed to prove. Thus, we have shown it. So I'm going to say that this was a difficult question, a tasty one. So yeah, I would totally recommend you to mark this one as it was interesting. Now let's head on to our next question. Now this is another question, and as you can see, it involves double angle identities. So I would recommend you pay particular attention to this one. So let's start solving. Before solving, uh, we have know that we have to prove that this equals to this. Okay, so tan, just for the sake of solving it, uh, making it easier, we can write the right hand side as tan 45 plus tan x upon 1 minus tan 45 tan x, because this is essentially what we have to prove. We have to equate left hand side, we have to simplify left hand side to get this, because once we get and this and tan 45 plus x are essentially the same. Okay, so yeah, let's start solving. Sec 2x can be rewritten as 1 upon cos 2x plus sine 2x upon cos 2x. All right, so we have here cos 2x upon 1 plus sine 2x. So yes, so 1 here can be written as sine square x plus cos square x, and sine 2x can be written as 2 sine x cos x, and this cos 2x can be written as cos square x minus sine square x. Right. So notice that in the above, in the numerator part, it can be written as sine square x plus 2 sine x cos x plus cos square x upon cos square x minus sine square x. All right. And this is basically a quadratic equation, which is an identity which is expanded as. So this can be written as sine square x plus cos sine x plus cos x square, which is a plus b square, and this can be written as a square plus 2ab plus b square. Okay, so we will just write it as it is, and in the numerator we can write cos square x minus sine square x. All right. So now what we are going to do is, notice this denominator is an identity a square minus b square. So we can write this as a plus b, a minus b, and the numerator will be the same. Okay. Notice that this and this cancels out. So we are left with sine x plus cos x upon cos x minus sine x. So we basically need to prove this to this. All right. Now, one thing we can work out here is that we know that 1045 is equal to 1, right? So we somehow need to get 1 here, okay? But it is already in its simplest form. So what we are going to do is we are going to divide cos x, divide cos x in the whole expression, in the whole expression. That way we're going to get 1 here. All right. So let's do that. Sine x upon cos x plus cos x upon cos x, the whole thing divided by cos x. In the denominator, we're going to do the same thing, because whatever is introduced in the denominator, the same thing is introduced in the denominator. Uh, whatever is introduced in the numerator, the same thing is introduced in the denominator to offset the effect of introduction. Sine x over cos x. Now this and this cancels out, and sine x over upon cos is equal to tan x. We can write this as tan x plus 1, or 1 plus tan x. All right, this is 1 and this is tan x. And this cancels out. We're left with 1 minus sine x over cos x, which is tan x. All right. Now we have to prove this 1045 plus tan x upon 1 minus 1045 tan x. So what we are going to do is, now we know that 1 is tan 45. So we're just going to write tan 45 instead of 1, tan 45 plus tan x. And we're not going to change this one because we need it, right? We need it. So yeah, 1 minus tan x. If there's nothing here, it is always 1. So we are again going to write 1045 here. 1045 plus tan x upon 1 minus tan x 1045. Now notice that this now equals this. All right. So now we can safely apply the identity tan 45 plus x. And thus we have shown it. All right. I know this may seem very intimidating and very confusing, but all these identities require our practice, 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 and practice. And once you start doing it on your own, I'm sure you will get the hang of it. Now let's move on to our next question. So here's our question 5. So yeah, we have to prove sine 2x equals this. All right. So we know that sine 2x is 2 sine x cos x. So how are we going to prove this to this? So yeah, we obviously have to introduce stuff. So what we can do is, we know that there is 1 in the denominator. So we are going to divide the numerator and the denominator by cos square x. Cos square x. And let's see. I'm doing this so that we get tan x in the numerator. All right. And to get rid of this cos x, 2 sine x cos x upon cos square x upon 1 upon cos square x. See, we got rid of this cos x. 2 sine x upon cos x divided by 1 upon cos square x. Sin x over cos x is equal to tan x. So we have 2 tan x and 1 upon cos square x is what is sec square x. All right. So we have this. Now we need 1 plus tan square x. We have learned an identity that tan square x minus sec square x is equal to 1. So 1, so sec square x is tan square x plus 1. So we can write sec square x as tan square x plus 1 or 1 plus tan square x. All right. So we're just going to write it that way. 2 tan x upon 1 plus tan square x because sec square x is equal to 1 plus tan square x. So yes, we have shown it. This was tricky yet straightforward. So our next identity. So this is identity number 5. Sorry, identity number 6. Why have I written 17 here? Yeah, this is 6. All right. So yes, so we have to prove that this equals this. So all right. We know that cosec square x is 1 upon sine square x and sec square x is 1 upon cos square x. So, and by the way, guys, whenever you encounter complex looking identities that look complex on the right hand side, it is always a good idea to do a bit of reverse engineering. All right, just to make things easier. So this for cosec square x 2x for cosec square 2x can be written as for sine square 2x, right? 4 upon sine square 2x. And we know that sine 2x is 2 sine x cos x. So it is 2 sine cos x square. All right. So we need to prove this in order to get this. All right. So I would always recommend you do a bit of reverse engineering in complex looking questions only. Okay. So yeah, we need to prove this. So let's just do that. Sine square x cos square x. This will multiply this by cos square x. We get cos square x here. And if we multiply it by sine square x, we get sine square x here. Now notice that sine square x plus cos square x is equal to 1. So we have 1 upon sine square x cos square x. So what we can do now here is that if we multiply the numerator by 4 and obviously the denominator as well, we get 4 upon 4 sine square x cos square x, which guys notice is the same thing as this. All right. So 4 sine square x cos square x, if we take the square common, we are left with 2 sine x cos x square, right? Which is, as we reverse engineered here, which is equal to 4 upon 2 sine x cos x square, all right? And which is here equal to sine 2x square, and that 4 into 1 upon sine square 2x is equal to 4 cosec square 2x, and that is exactly what we needed to prove. So what we learned here is that sometimes it is a good idea to do a bit of reverse engineering. All right. And remember, in these identities, at times you will have to introduce stuff like we introduced 4 here in the numerator and the denominator. So this is completely normal. In order to satisfy the left hand side with the right hand side, you will have to introduce stuff at times. Okay. So get used to it. So now heading on to our next identity. So here we have it. So tan 2x upon 1 plus sec 2x is identical to tan x. All right. Tan 2x can be rewritten as sine 2x upon cos 2x, the whole thing divided by 1 plus sec 2x. So sec 2s is what? Sec 2s is 1 upon cos 2x. All right. So let's simplify this first. Sine 2x upon cos 2x divided by cos 2x. 1 into cos 2x into cos 2x, we get cos 2x plus 1 here. And we would just reciprocal it. Cos 2x upon cos 2x plus 1. This and this cancels out, so we are left with sine 2x upon cos 2x plus 1. Right, and it's asking us to prove it to 10x. So right, let's do it. We know that sine 2x is equal to 2 sine x cos x, and cos 2x can be rewritten as 2 cos square x minus 1. And plus, we have plus 1 here. Okay, so 2 sine x cos x upon 2 cos square x minus 1 plus 1. This and this cancels out. And this This cancels out, this and this cancels out. So we are left with sin x upon cos x, which is equal to tan x. So we have shown it, right? So that was, yeah, that was easy. Okay. So one last identity for today. And let's start it. Now this says cot x minus y is identical to cot x cot y plus 1 upon cot y minus cot x. Cot x. So this is what we have to prove. So let's start. We know that cot x is cos x minus y upon sin x minus y, and cos x minus y is, we know that cos x minus y is cos x cos y plus sin x sin y, and sin x minus y is sin x cos y minus cos x sin y. Now notice that this cannot be simplified further. So what we are going to do is, since we need cot in the numerator and in the denominator, so what we can do is divide this whole thing by sin x sin y. All right. So cos x cos y divided by sin x sin y plus sin x sin y upon sin x sin y upon sin x cos y upon sin x sin y minus cos x sin y upon sin x sin y. Notice by doing this, we got rid of this sign. I don't have space. Let's just do it here with a blue pen. Okay, so we got rid of this and we're left with 1 here. And we got rid of let me just write it. Cos x upon sin x is cot x, right? And cos y upon sin y is cot y plus 1. The numerator is sorted. And in the numerator, we got rid of denominator, we got rid of sin y and sin y here. So we are left with, also we got rid of sin x and sin x. So cos y upon sin y is cot y, and cos x upon sin x is cot x. So yeah, this is what we had to prove. We have shown. So that's it for today. I hope everything was understandable. And I know these identities are difficult. I'm not going to lie that they are easy, but definitely with practice and with time and with consistency, you are going to surely get hang of it. And I can do a lot of questions here, but uh, you yourself need to practice as much as you can. Because even if I do like 20, 30 questions, they won't be enough. Believe me, they won't be enough. You have to solve at least 40 to 50 good quality questions from the past papers to get the hang of it, to get the grip of it. And that's the only way. I wish you best of luck. And in the next part, we are going to start off with harmonic identities, graphs, and uh, maybe one or more two concepts. And yeah, then we are done with trigonometry. And hopefully, we are going to do more questions as well. So that's it for today. Thank you. Take care. Allah Hafiz.